Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Kami daripada Grup 8 ingin membentangkan projek kami iaitu Application of Order Differential Equation. Pertama sekali kami ingin berterima kasih kepada lecturer kami Dr. Nashila kerana telah mengajarkan kami. Seterusnya ialah ni ialah grup member yang terdiri daripada Muhammad Ifan Fadli bin Ismail, Muhammad Afiq Ezam bin Muhammad Sulong, Muhammad Aiman bin Ahmad Irawan, Muhammad Syarul Rafi bin Muhammad Halik, Muhammad Amah Kimi bin Muhammad Maknum. Seterusnya ialah saya akan menerangkan tentang introduction. In mathematics, differential equation is an equation that contain one or more functions with its derivative. The derivative of the function define the rate of change of a function at a point. First order differential equation is a differential equation where the maximum order of a derivative is 1 and no other higher other derivative. Second order differential equation is a specific type of differential equation that consists of a derivative of a function of order and no other higher other derivative. Seterusnya saya akan terangkan tentang objektif projek kami. First, to solve differential equation analytically and numerically. Second, to analyze and interpret the solution of differential equation. And last sekali, to use differential equation as mathematical. Seterusnya ialah saya akan menerangkan tentang method used for the calculation. Yang first kali kita menggunakan first order differential equation, linear equation. First kali, macam mana nak buat ia, kita kena consider this first order linear differential equation. Sebagai contoh, dy per dt tambah 3y sama dengan 30 with y 0 sama dengan 3. Show that y per t sama dengan 15 tolak 12 e 2t by substituting this value and its derivative in the differential equation. First order differential equation is considered linear when it can be written in the following form. Dy per dx plus pxy equal to qx. In this form, px and qx are functions of the independent variable x and y represent the unknown function. To solve linear first order differential equation, we can use an integrated factor. Here are the steps to solve a linear first order differential equation. First, identify the coefficient p, x and qx in the given equation. After that, multiply the entire equation by integrating factor denoted by x, which is defined as the exponential of the integral of px with respect to x. Next is multiply both sides of the equation by use the equation above. Notice that the left hand side can be written as the derivative of the product of micro x and yx. So use the equation. After that, integrate both sides of the equation using the equation. After that, solve the integral on both sides. If necessary, solve for y in terms of x or vice versa. By following this step, you can solve linear first order differential equation. The integrating factor method allows us to transform a linear equation into a separable form, making it easier to solve. Thank you.
Okay, seterusnya saya Muhammad Aiman bin Ahmad Irawan akan membentangkan pula pasal method used for the calculation, iaitu first order differentiation equation, separable equations. Okay, yang pertama sekali, first order differentiation equation is an equation that relates an unknown function and its derivative. Separable equation are a particular type of first order differentiation equation that can be separated into two separate functions, one involving the dependent variable and the other involving the independent variable. The general form of a separable equation is given by dy per dx equal to gx darab dengan fy, where dy dx represent the derivative of the unknown function y with respect to the independent variable x, and gx and fy are separate function of x and y respectively. To solve a variable, to solve a separable equation, the goal is to separate the variable and integrate both sides of the equation. The steps involved in solving a separable equation are as follows. Rearrange the equation to separate the variables dy per fy equal to gx dx. Lepas tu, integrate both sides of the equation. Integrate 1 per fy dy equal to integrate gx dx. Lepas tu kita kena solve the integrals on both sides of the equation. If necessary, solve for y in terms of x or vice versa. It's important to note that not all first order differentiation equation are separable. However, when a first order equation can be written in the form dy per dx equal to gx darab fy, it can be solved using the separable equation technique outlined above. Okay, yang seterusnya, second order differentiation equation. A second order differentiation equation is an equation that relates a second derivative of an unknown function and potentially involve the function itself and its first derivative. Second order differentiation equation commonly arise in various scientific and engineering applications. The general form of a second order differentiation equation is d kuasa 2y per dx kuasa 2 tambah dengan px dy per dx tambah dengan qxy equal to rx. In this equation, y represents the unknown function, x is the independent variable, and px, qx, and rx are functions of x. To solve a second order differentiation equation, different techniques can be employed on the specific form of the equation. Some common methods include homogeneous linear second order equation. If the equation can be written in the form d kuasa 2y per dx kuasa 2 tambah px dy per dx tambah qxy equal to 0, where px and qx are functions of x, the equation is homogeneous. Technique is finding the auxiliary equation and using the characteristic roots can be used to find the general equation. Non-homogeneous linear second order equation, if the equation has the form d kuasa 2y per dx kuasa 2 tambah px dy per dx tambah qxy equal to rx, where rx is a non-zero function of x. The equation is non-homogeneous. Technique like the method of undetermined coefficient and variation of parameter can be applied to find the particular solution. Dan seterusnya, reduction of order. In some case, if the equation is of the form d kuasa 2y per dx kuasa 2 tambah px dy per dx tambah qxy equal to 0 and one solution of the equation is known, the method of reduction of order can be used to find a second linear independent solution. Power series solution. For certain types of differential equation, power series solution can be utilized. This method involves expressing the unknown function as a series and solving for the coefficient by substituting the series into the equation. It's important to note that the solution technique may vary depending on the specific form and characteristic of the second order differentiation equation.
Assalamualaikum dan salam sejahtera. Nama saya Muhammad Hafiz Izam bin Muhammad Suluh. Nombor matrik CN 220273. Okay, untuk application of first order differential equation yang kami pilih, yang pertama ialah first order differential equation dalam RC dengan RL circuit. Dalam soalan dia suruh cari first order linear differential equation untuk dy over dt tambah 2y tolak 30. Lepas tu y kosong dia sama dengan 3. Lepas tu dia suruh show yang yt equal to 15 tolak 12 et by substituting this value and its derivative in the differential equation. So first kami buat ialah menggunakan Laplace transform untuk mendapatkan value dia. Lepas tu lepas dah dapat dia punya equation by Laplace transform tu, kami menggunakan part expression untuk mencari nilai A dengan nilai B. So last kali kami dapatlah yt sama dengan 15 tolak 12 et. So benda ni ialah first order differential equation. So untuk yang kedua pun kami applykan Laplace transform untuk cari A dengan B. Untuk last kali dapat jawapannya ys equal to 5s tambah 10 bahagi dengan s tambah 5. So yt dah equal to 6 tambah 10a negatif 5t.
Assalamualaikum. Nama saya Muhammad Ibn Fadli bin Ismail. Salah satu seorang daripada guru ini. Saya akan menerangkan ialah application of first order differential equation. Contohnya ialah two 9-volt batteries are connected to a series in which the inductance is 1/4 Henry and the resistance is 8 ohm. And determine the current I if the initial current is 0. Jadi kita mula dari equation L is equals to 1/4 and R is equals to 8. Next E minus equals to 18. Dan equation seterusnya 1/4 differentiate I and over differentiate T plus 8I equals to 18. Itu ialah first linear differential equation. Dan bawahnya differentiate I over differentiate T plus 32I equals to 72. Next ialah U plus equals to EF 32 differentiate T equals to exponent kuasa 32T. Bawahnya ialah exponent 32T didarabkan dengan differentiate I dan differentiate over dt plus exponent power 32T and darab dan 32I equals exponent power 32T darab dengan 72. Dan akhir sekali ialah differentiate d over dt dalam kurungan exponent 32T didarab dengan I equals to 72 exponent power 32T. Bagi application of course bagi ini pula ialah application of second order differential equation. Solution which the given value of LRC and E so equal to 7 becomes D equals to D equals to 2 Q over dt kuasa 2 plus 40 differentiate Q over differentiate T plus 625Q equals 100 cos 10T. The auxiliary equation is R power 2 plus 14R plus 625 equals 0 with roots. and the equation is R equals to negative 14 plus minus power factor negative 900 over 2 equals negative 20 plus minus 15i. So the solution of the complementary equation is QCT equals exponent power 20t, and in the bracket is cos 50t plus sin 50t. For the method of undetermined coefficient, we try the particular solution. So the first equation is QP is equals to A cos 10t plus B sin 10t. The second is QT equals to negative 10A sin 10t plus 10B cos 10t. So the third is negative 100 A cos 10t minus 100 B sin 10t. Substitute into equation 8. We have negative 100 A cos 10t minus 100 B sin 10t and plus 40 in the bracket negative 10 A sin 10t plus 10 B cos 10t and plus 625 in the bracket uh, A cos 10t B plus B sin 10t equals to 100 cos 10t ataupun 525A plus 400B dan darab dengan cos 10t tambah dalam kurungan negatif 400A tambah 525B sin 10t equals 100 cos 10t. Equation coefficient we have 525A plus 400B equals 100, negative 400A plus 525B equals to 0, or 21A plus 16B equals to 4, and 60 minus 60A plus 21B equals to 0. And on the right is the solution on the system is A plus 88 667 and B sama dengan 64 over 697. So a particular solution is equals to 1 over 697 darab dengan 84 cos 10t plus 64 sin 10t. And the general solution is QT equals QCT plus QPT sama dengan exponent power negative 20t and darab dengan cos 15t tambah sin 15t dan tambah pula 4 over 697 darab dengan 21 cos 10t tambah 16 sin 10t. Supposing the initial condition Q of A equals to 0, we get Q0 C1 plus 84 over 697 equals to 0. dan C1 equals to negative 84/997. To impose the order initial condition, we first differentiate to find the current. So I equals d differentiate q over dt equals exponent power negative 20t, and in a bracket negative 20 C1 plus 50 C2, and darab dengan cos 15t tambah negatif 15 C1 tolak 20 C2 dan didarabkan dengan sin 15t tambah 40 per 697 dalam kurungan negatif 21 sin 10t tambah 16 cos 10t. Jadi I kita andaikan dapat 0 equals negative 20 C1 plus 50 C2 tambah 640 over 697 equals to 0. So C2 kita akan dapat negatif 464 over 2091. Thus the formula for the charge is QT sama dengan 4 over 697 and in a bracket exponent negative 20t over 3 dan didarabkan dengan negatif 63 cos 15t tolak 116 sin 15t ditambah dengan 21 cos 10t tambah 16 sin 10t. And the expression for the current is I sama dengan 1 over 291 2091 eksponen power negatif 20t dan darab dengan dalam kurungan negatif 1922 cos 15t tambah dengan 13,060 sin 15t tambah dengan 120 didarabkan dalam kurungan negatif 21 sin 10t tambah 16 cos 10t. Jadi untuk soalan terakhir ni kita akan tengok macam ni kita cuba untuk dapatkan particular solution. Yang pertama ialah d 2x over dt kuasa 2 itu ialah acceleration, plus 5 dx over dt itu ialah velocity, plus 6 x itu ialah displacement equals to 0. Time t equals to 0 second, x sama dengan 0.1 meter, to differentiate x sama dengan 0.15 m per second. So untuk auxiliary equation, m is sama dengan t m t plus 6 equal to 0 dan differentiate m kuasa 2 tambah 5 m tambah 6 sama dengan 0. So factorize kita akan dapat dalam kurungan m tambah 2 dan m tambah 3. So m sama dengan negatif 2 atau m sama dengan negatif 3. So the roots are real and unequal. So the general solution is x sama dengan a exponent negatif 2t plus b exponent 3 negatif t3 3t. So x sama dengan 0.1 sama dengan a exponent negatif 2 t sama dengan 0, so masukkan 3 dengan 0 tambah b exponent power negatif 3 sama dengan t ialah 0 jadi t is 0. So 0.1 sama dengan a plus b untuk first equation, and the third equation is 0.1 kita pindahkan a jadi 0.1 minus a equals to b. So for dx over dt equals to negatif 2 ae negatif power negatif 2t tolak 3b exponent power negatif 3t. Dan gantikan dx tu ialah 0.15 sama dengan negatif 2 a in negatif power a exponent power negatif 2 sama dengan t ialah 0, so tolak 3 di exponent power negatif 3, t ialah 0, so gantikan dengan kosong. Dan kita akan dapat negatif 0.15 equals to 2a plus 3b. Dan yang bawah tu ialah negatif 0.15 sama dengan 2a plus 3, dan gantikan dengan equation yang atas. Kita dapat 0.1 plus minus a. So 2a plus 0.3 tolak 3a. Yang bawah tu ialah 0.15 plus 0. Sama dengan 0.3 tolak a. A kita akan dapat 0.45. So gantikan dalam equation yang sebelum tadi, kita dapat dalam equation yang ketiga 0.1 tolak A ialah 0.45, so B equals to 0.35. So for the particular solution is x equals to 0.45 exponent power negative 2t minus 0.35 exponent power by negative 3t. In conclusion, the report highlights the wide range of applications for first and second order linear differential equations. These equations serve as powerful tools in modeling and understanding dynamic systems in various scientific and engineering domains. Through the applications of appropriate solution techniques, they enable the prediction and analysis of complex behaviors, providing valuable insights and contributing to the advancement in different fields. Further research and exploration in this area can even lead to even more significant advancements and practical applications. Finally, the application of first and second order linear differential equations provide a robust framework for analyzing and understanding dynamic systems. By utilizing these equations and their solution techniques, we can make accurate predictions, optimize system performance, and advance scientific and engineering knowledge. Continued research in this field holds great potential for further advancement and applications in a wide range of disciplines, contributing to the progress of society as a whole.